This is a video for OCR Pure Core Mathematics, Complex Numbers 6, Exponential Form, 6.3, Expressing Sine Theta and Cos Theta in terms of complex numbers. Let's look at some useful results. For a complex number, z is equal to x plus iy, we can use the exponential form to show this. Let's see how that works. If we start with e to the z, well, that's equal to e to the x plus iy. But we know that this just means e to the x times e to the iy. And we know that e to the iy is cos y plus I sine y. So this is just e to the x times cos y plus I sine y. And this particular result can be very useful later when we look at some integration. We can also find an exponential form for this thing here. If we rewrite in terms of minus theta, so if I rewrite that as cos of minus theta, remember cos is even, so cos theta is the same as cos of minus theta, and then plus I sine of minus theta. And sine is an odd function, so sine of minus theta is minus sine theta. Then quickly we can see that this is r e to the minus I theta. That's just written out a bit more neatly for you, but it's exactly what I had on the previous slide. Let's have a look at these two, and as a result we'll get some results for cos theta and sine theta. This is going to be cos theta plus I sine theta plus cos theta minus I sine theta. And so these two cancel out, leaving me with just 2 cos theta. Well, if 2 cos theta is equal to this, then I'm going to get that cos theta is equal to e to the I theta plus e to the minus I theta all over 2. And this is very similar to the expression for cos x, which is e to the x plus e to the minus x all over 2. Now if we look at this one, I'm going to get cos theta plus I sine theta minus cos theta minus I sine theta. And this just gives me, this time the cos's are going to go, and it's going to give me 2I sine theta. And so this gives me an expression for sine theta, which is e to the I theta minus e to the minus I theta all over 2I. Now it's important to remember that there's this 2i on the bottom, but also, as we did with cos, we can compare this with the formula for sin x, which is e to the x minus e to the minus x all over 2. Again, there's that written up more tidily for you, and we come through to our 2 key results here and here. So in summary then, both cos theta and sine theta can be written in terms of complex numbers, and it's important that you recognize these, that you're able to recall them quickly, and that you know where they came from. They're very similar to the definitions for the hyperbolic functions, cos x and sin x, and you need to remember that there is a 2i in the expression for sine theta. So just be aware of that and make sure you remember it. The next video in this sequence is 6.4, using the exponential forms of sine theta and cos theta.